Hello everyone. In this video I'm gonna talk about how we consider the accuracy or precision of the number that we are working with. In our calculations, sometimes we have numbers that they have 2 digits after decimal, some of them they have no digit after decimal, some of them has 5 digits after decimal. And when we are adding or subtracting or multiplying this number, we don't know, or we are not sure how many digit after decimal we should consider. Or when we are measuring something, how many digit after decimal we need when we are measuring something. All of these topics I'm going to cover in this video. Actually, in this video I'm going to talk about approximate numbers, exact numbers, what are the significant digits in a number, what is accuracy, and what is precision, and what is the appropriate unit. These are the terms or topics that I'm going to cover in this video. What is the approximate number? When we are measuring something, usually or most of the time, our measurement result is approximate. Let's say I am measuring the length of this marker. Let's say I'm using a normal ruler or normal tape to measure this marker, and the result is 12 centimeter. Now imagine that I measure it with more attention. I want to measure it with more accurate. Okay, if I look at the tape or the ruler, maybe my exact number is 12.4 centimeter, the length of this marker. Now imagine instead of using ruler or measuring tape, I use a micrometer or I use a caliper, more accurate device to measure this one. Using the accurate device, maybe this length of this marker is gonna be 12 and 435 thousandths of centimeter. Can you see how the measurement of this, the length of this marker is depends how I'm gonna measure it and what type of device I'm using. All of this one are right, but all at the same time, all of these numbers are approximate. Because if I use more accurate device, again I can keep going, my precision is going to be more and more and more, and I will not 100% aim to what is exactly the length of this marker. This is one example of approximate number. Or let's say I am weighting myself. I want to know how much is my weight. Let's say my weight is 72 kilograms if I use a normal scale. If I use more accurate scale, my weight maybe is 72 and 0.4 kilograms, or 72 and 450 kilograms, or 72 kilograms and 450 grams. As you see, again, all of these numbers are approximate because it depends how much accurate or how much which type of device or a scale I'm using to weigh myself. All of these numbers, we call them approximate number. Anything related to measuring something is going to be the result going to be approximate. Now, on the other hand, let's say I'm counting the number of students sitting in the class. The number of students sitting in the class, if I end up to 25 students, these 25 students is exact number. It means exactly 25 students are sitting inside the class. It's not 26, it's not 24. It's exactly 25. Or let's say I'm asking you how many markers I'm holding in my hands. So I'm holding exactly 3 markers in my hand. It's exactly 3. It's not 4, it's not 2. So exact number, usually when we are counting something, the result is going to be exact. So approximate number, exact number. Now imagine Imagine I want to measure the distance between two cities of Toronto and Montreal. The distance between these two cities is 541 kilometers. Is 541 kilometers. Okay, the distance between these two cities is 541 kilometers. Can I say the distance between these two cities is 541 kilometer 372 meter, or 541,372 meter? Is this unit or is this measurement make sense? When we are talking about distance between two cities, the number of meter, 2 meter or 72 meter or 300 meter, is not the unit that makes sense, because it depends from which point to other point of the city, which point from this city is our starting point, which point from the destination is gonna be our ending point. So this meters, it doesn't make sense. So even for this one, if I write 541,000 meter, again this 30 doesn't make sense. So we say this unit, meter, for measuring the distance between two cities, the meter is not appropriate unit. We use kilometer to measure the distance between two cities. On the other hand, when I'm measuring a length of a desk, let's say I have a desk and the length of this desk is 150 centimeter. This 150 centimeter is appropriate unit for measuring the length of a desk. Or I can say 1.5 meter. Again, is appropriate unit to measure the distance, the length of a desk. But if I say is 10,000 or 0.0015 kilometer, using kilometer for the length of a desk is not the appropriate unit. Okay, so when we are measuring something, when we are using a unit or explaining the unit, be careful that we should use appropriate unit. When I'm measuring the height of a person, it's gonna be feet or centimeter or meter. Height of a person, using kilometer or using micrometer for height of a person is not appropriate unit. Now, if I say, let's say my weight is 160 pounds, okay, and I want to convert my weight to kilograms. I know that 1 pound, 1 kilograms is 2.205 pounds. I want to use this information to convert 160 pounds as my weight to kilograms. For converting 160 pound multiplied by, because we have pound at the top right, pound at the bottom, and then we have 2.205 pound is 1 kilogram. Now, because I'm looking for kilogram, this is the unit I'm looking for it. This pound and this pound cancel each other. Multiply all the number at the top, right in the top. Multiply all the number at the bottom, right in the bottom. So 160 times 1 is 160, divided by 1 times, this is 2.205, and the unit gonna be kilograms. If I use calculator to divide 160 divided by 2.205 kilograms, what gonna be the answer? 160 divided by 2.205, the answer gonna be 72.56235623 5828, and it's keep going. The calculator doesn't have more space to show, and is kilograms. So 160 pound is end up to 72.5623 5, 6, 2, 3, almost 10 digits after the decimal. So do I need to keep all of these digits after the decimal? No, because I'm looking for my weight. I don't need this much of accuracy, and actually this number is not accurate because look at this part. I don't have digits, these too many digits after the decimal. 160 pound, no decimal after the digit, and this one has only 3 digits after decimal. So this number, even if I keep it, is not accurate. Okay, so how we can reserve the meaning that again is not appropriate unit, this number of digit, we shouldn't keep it because actually it doesn't have meaning even though the calculator end up to this one. How many digits we should keep? We go back to this significant digit. Now let's go back to definition of this significant digit. The significant digit is the number of accuracy, or is the amount of accuracy that we need and we should keep in our calculation. The number of significant digit. Let's say, what are the rules of the significant digit? I go back to the previous example, the distance between these two cities. If I say the distance between Toronto and Montreal is 541,000 meters, okay? As I explained in the example, these two zeros doesn't have meaning. So for this one, the number of significant digit is only these 3 non-digit. These 30 is showing for keeping the place value of this number. This 0, it means we don't have any digit in place value 1, no digit in place value 10, no digit in place value of hundreds. Yeah, so it means these are only place value holder 1, 10, hundreds. Okay, so this number we have only 3 significant digits. Okay, if this number has only 3 significant digits, the ending 0, it doesn't count as a significant digit. When I say 25,000 milliliter, again this 30 doesn't count as a significant digit. I can write it as 25 liter, and this 3 zeros is only placeholder, so has only 2 significant digits. Okay, now the place value for keeping the decimal, as an example, this one 001, okay, is 1 thousandths. Okay, as an example, I can say this one is 1 thousandths of kilogram, but I can say it's 1 gram. Can you see how if I multiply by 1,000, kilogram converted to gram? If I write it as a kilogram is 0.001, but if I convert it is 1 gram. Again, because these 2 zeros after the decimal, so this is the 0 before decimal, it doesn't count, then this is the decimal, then these 2 zeros, because these 2 zeros is just for placeholder, it just tell us that in the place value of tenths and hundredths there is no digit, so we don't count it as significant digit. So this number has only 1 significant digit. Okay. The other example that I can show you, 408,000. Okay, this number has 3 significant digits because we don't count the ending zeros only. The middle 0 is considered as significant digit. So this number has 3 significant digits. The other example, 4.000. Okay, this number, look at here. Okay, because when we write a number as a 4.000, it means, before explaining this one, this number has 4 significant digits, because these zeros is after the decimal is considered as a significant digit, same as this one, 4.001. Again, this number has 4 significant digits. 1, 2, 3, 4 significant digits. Now, let me explain why this one we consider this 0 as a significant digit. Look at this one. Let's say I have this number 4.29, okay, and I want to round it to the nearest, 92, 95. Okay, let's say I want to round this number to the nearest tenth, this location, one digit after the decimal, which is 10. Rule of rounding. Look at the next digit after the decimal. If it's 5 or greater than 5, drop it and add 1 for this one. So if I round it to the nearest tenth, it's going to be 4.0. Because this one is 5, if I add 5.0. 5.0, because if I add 1 to this 9, 1 plus 9 is going to be 10, and 4 plus 1 is 5. Now, 4.95 or 4 and 95 hundredths, rounding to the nearest 10 is going to be 5.10 or 5 and 10th. Can I eliminate this one? Can I eliminate this 0? Can I write it as 5? No. Why? Because if I write it at 5, it means 5 means my accuracy is up to whole number. When I'm writing 5, it means it can be 5.0, it can be 5.1, 5.2, 5.3, and 5.4. Right? All of this number, if I round it, is going to be end up to 5. Okay, but remember the original number was 4.95, 4 and 95 hundredths, and I rounded to the nearest 10. When I'm writing this 0, it means I care up to 1 digit after decimal. If I eliminate this 0, it means I care up to whole number. So these two numbers are different. That's why when we are keeping zeros after the decimal, we consider it as significant digit. Okay, now for the same reason, 5.0, this number has 2 significant digits, and 5.000 has 4 significant digits. Okay, so zeros after the decimal considered as significant digit. Or 5.0005. This number has 1, 2, 3, 4, 5 significant digits. Another example, I use this one, but 0.004. This number has only 1 significant digit because these 2 zeros after decimal is used for place value holder. Another example, 0.000503. How many significant digits does the number have? This 30 doesn't count as a significant digit because they are place value holder, and we have only 1, 2, 3, so I have 3 significant digits. So these are the meaning of significant digits after for count the number of significant digits in a number. In simplified format, when we are seeing a number, all non-zero digits are significant. All non-zero digits are significant, and zeros placed between two non-zero digits, between two non-zero or two significant digits are significant. Okay, example for this one, 705. This 0 is considered as significant digit. But for this one, 705 and 000. These 0 are not significant, but this 0 is significant digit. The other thing, if we have zeros between two sides of decimal, as an example, 70.00, all of these zeros are considered significant digits. Okay, so this number has 4 significant digits and 70.001 has 5 significant digits. So zeros between in both sides of the decimal is going to be considered as significant digit. Zeros on both sides of decimal. Decimal point are significant digits. Okay, so these are considered as significant digit, and I explained to you. Now, let's talk about precision and accuracy. What is the precision and what is the accuracy? A number with more significant digits are accurate. As an example, 705 and 700. How many significant digits? The top number. The top number has 3 significant digits. What about the bottom number? The bottom number has only 1 significant digit. So top number are more accurate than bottom number. The numbers with more significant digits are more accurate. Okay, or this number 7.001 and 7.000. How many significant digits this number has? The top number has 1, 2, 3, 4 significant digits. What about the bottom number? 1, 2, 3, 4 significant digits. So this number have the same accuracy. But if I remove this one, if I compare these two numbers, okay. Now, how many significant digits has the top number? 4. 1, 2, 3, 4. How many significant digits the bottom number has? Only 1. So, bottom number, top number are more accurate compared to the bottom number. Remember, the number with more significant digits are more accurate. Now, the other thing about precision. Let's compare these two numbers. The top number, we have 3 digits after the decimal. What about the bottom number? In bottom number, we have 4 digits after the decimal. So the bottom number is more precise compared to the top number. For precision, the more digit after the decimal, it means more precision compared with the other number. Let's use example. $39.72 and 39.7. These two numbers, which of them are more precise? The top number, the precision is up to hundreds. The bottom one, the precision is up to tenths. So the top number is more precise compared with the bottom number. Which of them are more accurate? The top number has 4 significant digits, the bottom number has 3 significant digits. So the top number is more accurate. The number with the more significant digits are more accurate. The number with more digits after the decimal is more precise. This is the difference between precision and accuracy. Now, when we are adding and subtracting the numbers, okay, in addition and subtractions of approximate number, remember this accuracy and precision, all of them are for accurate or approximate number. For exact number, the numbers are exact because we end up with counting. And we are talking about approximate number. When we are adding or subtracting approximate number, let's say I am adding 5.2 plus 3 plus 9.32 okay? When I am adding the numbers with different precision, the precision of the result is the precision of the minimum or less precise number. This one is the precision for the first one is 1 digit after the decimal. This one is whole number. This one is 2 digits after decimal. So when I'm adding these numbers, okay, is 5 plus 3 is 8 plus 9 is 17 point, and let's add them 3 9.32. It's gonna be 2 5 and 12 17. Okay, the result is gonna be 17, but the precision of this number is only for the whole number. It means this 52 is not gonna be considered. The result of the precision is gonna be the whole number. But when I'm adding this one, I can round this one to 18. I can round this one to 18. So, remember, when we are adding the numbers, the precision of the result is equal to the least minimum precise number or least precise number, which is in this case is 3. In multiplication and division, the accuracy of the result is the minimum accurate number. As an example, if I am dividing 32.8 divided by 4.2, okay, when I'm dividing these two, the accuracy of this number is 3. The accuracy of this number is 2. So my answer is only the accuracy of my answer gonna be equal to the less accurate number, which is gonna be 2. If I add this, if I divide this result, 32.8 divided by 4.2, the result is 7. The result is going to be 7.809 and so on. Okay, this is the result. Now, which number I should accept? How many digits after decimal I should accept? Because I have my accuracy, maximum accuracy for this one, or the minimum accuracy for this one is 2. I should keep only 2 digits after decimal. So these 2 zeros, these 2 digits after decimal, is not acceptable. I don't accept this one. The final answer is gonna be 7.8. The same thing in multiplication. If I multiply 32.8 multiplied by 4.2, the result of this multiplication is gonna be 32.8 multiplied by 4.2 is gonna be 137.76. 137.76. Now, how many accuracy do I have? Is 4 point is 2 digits after the decimal. Okay, this number has 2 significant digits. This number has 3 significant digits. So this number for me is gonna be only 2 significant digits. If I round it, it's gonna be 100 4, okay, and sorry, this, not these two zeros, because if I put this zero, it's gonna be 100 significant digits. So 32.8 multiplied by 4.2, because this is the result, because it has only two significant digits. Okay. And in finding a root of a number, as an example, root of 5, okay, the accuracy of the result, if I find the square root of 5, the square root of 5, it gives me 2.23, 2, 3, and so on. But because I have one significant digit, I can say the accuracy of this one is 2. So these are the meaning of significant digit. I hope you enjoy this video. Bye for now.